So the next thing I want to do, get into some new stuff, we're going to talk about the specific groups of the periodic table. We don't need to know every single column on the periodic table, but we are going to go through a bunch of them and learn some of their properties. So we're going to start with group 1. It is the first column on the periodic table, but one thing I do want you to notice right now is that even though we're talking about group 1, hydrogen is not included in this list. We're just talking about the green, so we're talking about from lithium all the way down to francium. Okay, so lithium down to francium. All those elements have a valence configuration of ns1. Since we're talking about lithium, which is in the second energy level, it starts with 2s1. And then you work your way down 3s1 and 4s1 and 5s1 and so on. So they all have one valence electron. Okay? It turns out this one valence electron makes them super reactive. In fact, they are the most reactive of all metal groups. Something kind of weird or strange about the alkali metals is that even though we think of metals as being durable and strong and hard to dent or do anything to, it turns out alkali metals are extremely soft. You could literally take a butter knife and cut through a piece of lithium. So extremely soft. They are shiny and they do have a silvery look to them, but because they're so reactive, a lot of times if you just leave them open to air, they'll actually get really dark or oxidized, kind of like rust, but they turn like a dark gray or black color. If you cut away or shave away that dark gray or black, they will be shiny and silver for a bit until they react with the air and they become dark again. Now, a really cool kind of crazy property that a lot of people know about is that the alkali metals react violently with water, meaning they give off a lot of energy, and in that process they make a bunch of hydrogen gas. Well, hydrogen gas is flammable, so a lot of times this violence, this huge reactivity, will trigger that hydrogen gas to explode. So you get really neat pyrotechnics like this picture here, where they've taken a massive amount of potassium and dropped it in water. You get this crazy explosion. Okay. Now, the last thing I want to talk about with alkali metals is I want to relate them back to video 5-3. We talked about three things in video 5.3. We talked about radii, meaning the size of the atom. We talked about ionization energy, which is referring to how tight the atom holds on to its electrons. So how tight it holds onto electrons. So if the ionization energy is high, that means it's really hard to pull off the electrons. In this case, the ionization is low, which means that it's very easy to pull off electrons. So how tight it holds onto electrons. So in this case, ionization is telling us that it's easy to remove electrons. Okay. Now, over here, I skipped it, but large radii just means these are the biggest of all the atoms. So if you remember the trend, or actually the phrase that pays, I guess, France gets fat eating french fries, meaning francium is the largest, means that group 1, being all the way over here on the left-hand side, is the largest of all the atoms. Each of these elements has the largest atom for its period. Okay. And then the third property from 5-3 is electronegativity. And electronegativity is the element's attraction for additional or more electrons. So in other words, if you had a high electronegativity, you would have a big attraction for picking up more electrons. But in this case, we have a small electronegativity, which means that group 1 doesn't like to pick up extra electrons. So if we put this all together, they're very big atoms. They don't care too much for their electrons. It's easy to pull them off, okay, because of their ionization. And they don't want to pick up electrons, okay? They have really low electronegativity. This makes sense based on what we've learned in terms of ions, because everything in group 1 wants to lose one electron. If they do that, that will move them back to the previous energy level, and they'll have the same valence configuration as a noble gas, right? In other words, if you're in group 1, when you form an ion, you lose one electron, and your charge becomes +1. So all of these guys in group 1 form a +1 ion. It's not kind of a messy writing. I'm trying to write +1. Okay, so that's group 1. Again, they're called the alkali metals. Second group I want to talk about, it's really a group all by itself. This is hydrogen. We said hydrogen was not considered in group 1. It is the exception. Hydrogen is all by itself. it still has one valence electron, just like the elements that are in group 1, except that its configuration is 1s1. Okay, but the reason why it doesn't go into group 1 is that its properties are very different from the rest of the one valence electron elements. First of all, it's a gas at room temp. Okay, it is not an alkali metal. Again, say it one more time. It is not an alkali metal. It's in a group all by itself. It is flammable. Okay, notice down here this picture of this Zeppelin blowing up. This is the Hindenburg. They used hydrogen because it's a very light gas or low density gas to raise this Zeppelin. But the person or whoever it is that designed it didn't quite do their math, and what they did was they filled a balloon with a lot of flammable gas for spark, and the whole thing blew up. So kind of an interesting weird fact about hydrogen is that 75% of the mass in the universe that comes from matter is hydrogen. If we turn that into atoms, it turns out about 90% of the atoms in the universe, so of all the matter, if we were to count up all the atoms, 90% of those atoms, again, are hydrogen. So hydrogen is the most abundant element in the universe, and it is in a group all by itself. Now we're moving on. So now we're looking at alkaline earth metals. This would be group 2. So we've moved over one group or one column on the periodic table. Okay. They have a valence electron configuration of ns2. So they're going to be things like 2s2, 3s2, 4s2, and so on. Now notice I did not put 1s2. Why? Well, 1s2 is over here. This is helium. And it turns out helium belongs to the last group of the periodic table. So even though it has the same number of valence electrons, okay, it doesn't fit in the alkaline earth group. Okay, these guys are all metals. So they have a silvery white color, they're shiny. In fact, they are very reactive metals. Not as reactive as group 1, because those are the most reactive, but close. Okay, in terms of radii, ionization, and electronegativity, they're almost as big as group 1, because they're still on the left-hand side of the periodic table, so pretty big. They have greater ionization energy than group 1, but it's still very low. Okay, so it's easy to take their electrons, easy to lose electrons. Okay, because they have low ionization energy. They're all the way over here on the left side. In terms of electronegativity, they have low attraction for electrons because they have low ionization. So low attraction, for electrons. And this makes sense because just like group 1, these guys want to lose electrons to get to their octet. So they'll actually lose 1, 2 electrons by going here. This is going to send them all the way back to here, to the previous energy level, right? So they will lose 2 electrons to get their octet, which means that when they form ions, they're going to form a +2 charge because they lost 2 electrons.